Okay, so this is what we just did. We've just made a sub-VI out of the code that we had created. It's called the shooter aiming sub-VI, something like that. These are the instructions for making that happen. What you end up with when you have made the shooting sub-VI and brought it into the new code is you have code that looks like this. And this shows you exactly what a useful sub-VI has in it. So notice, if I hit Control H, this has an input. So I can get information from the program that I'm living in now. The input that I give, that I have, is called my height. So this program will create a my height from some place. Maybe it uses a camera algorithm to figure out the center of the goal, right? And that height will become a number, and that number will be able to go in here. And then out of this algorithm, I get my shooting instruction for the user. If I right-click on this and go to the front panel, you can see that automatically this has created some connections on my connector pane. Remember when I said there were colors up there, that means things were connected. There is this input. If you click on a color, it'll show you what it's connected to. My height, for instance. If I click on one of these other colors, these are all indicators, so they're outputs. Notice that the outputs are on the left, and the outputs are on the right, and the inputs are on the left, right? Correct, I mean? The left, right? There we go. So, these are the three outputs. These are the three indicators. The green one is connected to too high, question mark, which is a Boolean light. There's the measured height, which just repeats back the measured height. And there's this string, which gives the instructions. Now, how many squares are in the connector pane? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 12, right? So that means that you can only bring in, if you bring in information one wire at a time, you can only bring 12 things into a sub-VI, and you can't send anything out. Or you could bring in 11 things and send one thing out, right? Because there's only 12 connection points here. So that would be a real drag if that were an actual limitation to LabVIEW, because maybe you've got a complicated algorithm that needs a lot of information. It turns out that one of the ways to solve this problem is to use a function to create a new data type that's very important in the robot code. The new data type is called a cluster. And a cluster, if I come back to my information here, I'm going to go, I have the whole set of slides that are additional slides that would have made me talk an awful lot to explain them. But one of them that's very useful is the cluster slide. So this is the cluster slide. The cluster slide shows that what a cluster is multiple pieces of data on one wire. Clusters are created by a function called a bundle function. It's actually a strange naming convention, because you'd think you'd just cluster things up to make a cluster, that the function would be called cluster. But just like you have a pig in the field but you eat pork, one is the French word, by the way. The prepared food is French, and the pig is Old English, because the French took over England in 1066. Anyway, same thing with beef, right? You don't eat cow, you eat beef. Beef is the French word for cow. Okay, there we go. Great. Take that home and think about it. So you bundle things to make a cluster. You bundle them to make a cluster. So let's take a look at what that looks like in LabVIEW. This isn't going to be an exercise. You could do it as an exercise, but I want to get into the robot code. So I will show you bundling happening, and then we will use the fact that there are clusters in the main code to understand the main code. So here's a bundle function. Right click. So that's the bundle function. You can resize it so that there are multiple inputs. Notice there are lots of inputs and one output. So let's take all three things. We'll do the height. We'll put it into the cluster at position 1. We will do the greater than question mark. We will put that into the cluster at position 2. And we will put string into the cluster at position 3. Now if I do my trick again and I right click on this and create an indicator, you'll see that Control H, there are 3 things on this wire. So you can use Control H to understand what's on a very complicated wire. And any wire that's thick is complicated. Notice that these are all thin wires. Here, thinner. And that's a complicated thick wire. So what's on this wire? It is a 64-bit real number. You don't have to know the 64-bit part, but it's a number. What's on this wire? It's a string. What's on this wire? It's a Boolean, or a true or false. What's on this wire? Well, it's a cluster that contains a number, a Boolean, and a string. They're all in there, and one of them has a name called my height. In most of the clusters that you're going to see in the robot code, you're going to have all of the items in the cluster named. Does that make some sense? Now, again, if we had a little more time, we might actually, well, we would hook this, I would have you guys hook this cluster up to an output terminal, because now I've got 3 outputs here. If I want to put all 3 of those outputs on one output terminal, I click on the terminal, and I click on the cluster, and now 3 things are coming out of that one location. And now I can free up these other ones by disconnecting them. So now I have an infinite number of inputs and an infinite number of outputs, because I can always bundle information onto one wire and bring it in through one input terminal, and I can always take any information that my sub-VI creates and put it out on one output wire. Another thing that I could have you do, if we had more time, is you can double-click on this icon. If you double-click on this icon, you get an icon editor. Here's the icon editor, and you can turn this into a very pretty picture that's more like a shooter. So I could call this shooter, and now I actually know what this code does. If I say OK, now I've changed this to shooter. I close this, I save it, and now you know exactly what this bit of code does. It's not some weird picture. It tells you exactly what its function is. It's self-documenting code. One other grab bag thing to bring up right at the end is, or at the end of the LabVIEW part, is you can document your code at any point by double-clicking and typing. This is my case structure for shooting. You can double-click and start typing anywhere. This wire has height on it. And now, I'm not looking at this and going, oh, what do these case structures do? I can say, oh, this is what this part of the code does.
You can also point to it now.
You can also point to things. Oh boy, here we go. My experts are telling me. How do I do that?
See the little arrow?
See the little arrow?
Right.
Oh, right here. Look at this. Ah!
Thing.
Look at that. See, every time I teach Lab, I've been teaching LabVIEW for 13 years, and every time I teach it, I learn something new.
That's brand new. 13.
That's brand new. So there you go.
And the nice thing is if you move your case structure, your comment moves with it.
Oh, now if I move this, at least the arrowhead moves with it. That's great. Okay, good to know. So if you want to make code that's readable, this is going to help. That's the end of the LabVIEW environment understanding and function understanding and programming part of this. Now we're going to open up the code for the robot, and we're going to walk through it using what we've just learned in the last 2 hours, right? So that you'll understand basically what's going on. And we'll make one small modification. We'll turn the robot code from arcade drive into tank drive. And I'm going to stop this because that's a good stopping point.